In this video, we're going to look at the sum and difference identities, problem type 1. And so in these problems, we're asked to find the exact value of a sine or cosine or tangent problem. And this is really just about being able to identify what makes up two angles and then using the sum or difference formulas. So if you think about 75 degrees for our first one here, the sine of 75 degrees. So 75 degrees is not one of the places on the unit circle that we just know, but 75 is in fact equal to 45 degrees plus 30 degrees. And 45 and 30 degrees are two angles we know on the unit circle. So this looks like the identity, the sine of alpha plus beta, and that's actually equal to the sine of alpha cosine of beta plus cosine of alpha sine of beta. And so if I work that out here, in this case, the 45 degrees is my alpha and the 30 is my beta. So we're talking about the sine of 45 degrees, the cosine of 30 degrees, plus the cosine of 45 degrees, sine of 30 degrees. And so if you look these up on the unit circle, the sine of 45 degrees is root 2 over 2. The cosine of 30 degrees is root 3 over 2. Plus the cosine of 45 degrees is another root 2 over 2. And the sine of 30 degrees is 1/2. So we end up with root 2 times root 3 over 4 plus root 2 over 4. And root 2 times root 3 is root 6. So root 6 plus root 2 all over 4. So not too bad. Here, pi over 12. So I need to think of two angles. Sometimes it's hard when you're doing these to think of the angles in terms of pi. So you could always convert, right? You could take pi over 12 times 180 degrees over pi, just so that you are able to figure out what those degrees should be. So if I do that division here, we end up with 15 degrees. So this is the same as saying the cosine of 15 degrees. And we can think of the cosine of 15 degrees as the cosine of 45 degrees minus 30 degrees. And so now we're just gonna, we're gonna apply the identity. Pull my screen down here a little bit. We're gonna apply the identity that the cosine of alpha minus beta is equal to cosine alpha cosine beta plus sine alpha sine beta. So in this case, we're talking about looking at the cosine of 45 degrees, the cosine of 30 degrees, plus the sine of 45 degrees, sine of 30 degrees. So this would be root 2 over 2 times root 3 over 2, plus, this is going to be root 2 over 2 plus, not plus, times 1/2. So we're going to get root 6 over 4 plus root 2 over 4. So in this case, we happen to get the exact same answer, root 6 plus root 2 over 4. That is not the answer to every single one of these problems, but it just so happened to work out this way. And we'll look at one more here. And I kind of started it already. So we're looking for the tangent of minus 105 degrees. And you can think of minus 105 degrees as the tangent of 45 degrees minus 150 degrees. And both of those are on the unit circle. So this is going to, so if we look at our formula here, the tangent of alpha minus beta is going to be the tangent of alpha minus the tangent of beta all over 1 plus the tangent of alpha tangent of beta. So if we plug in here, that's going to be the tangent of 45 degrees minus the tangent of 150 degrees divided by 1 plus the tangent of 45 degrees times the tangent of 150 degrees. So this is going to be equal to, the tangent of 45 degrees is 1, so 1 minus the tangent of 150 degrees is 1 over the square root of 3, all divided by 1 plus 1 times 1 over the square root of 3. So we have 1 minus 1 over root 3 divided by 1 plus 1 over root 3. And so I'm going to actually multiply the whole entire top by root 3 and the whole entire bottom by root 3 just to make stuff look a little nicer here. So we're going to end up with root 3 minus root 3 times the 1 over root 3. The root 3's would cancel and we just get minus 1 divided by root 3 plus 1. And so that would be my final answer.